In this week, week 8, we are going to talk about annuities and mortgages. We're going to be building on the simple interest and the compound interest formulas that we've been using for the last couple of weeks, but we're going to take it just one step further and look at how these formulas can be used for much longer periods of time. An annuity might be a new word to you, but it is a series of regular payments or deposits. So everything that we've done so far has looked at putting one deposit in an account and letting it grow. But let's say you're willing to make reoccurring deposits, say so much per month or so much per year into an account, and you're going to let that grow over time. It can also be used as a way to calculate payments over time, such as for a mortgage. So let's look at the general formula first, because you're going to be using this frequently. We'll call this the general form. So the payment is A, which is the amount that you're going to borrow. R and N have the same values that they've had all along. A times the rate over number of periods divided by 1 minus 1 plus the rate over the number of periods raised to the NT. And remember, N is the number of periods per compounding period and T is the number of years. And I've given you those definitions of what all those letters are right here. A is the amount of the loan, R is the interest rate, N is the number of installment payments per year, and T is the number of years. So suppose you want to borrow $12,000 at 12% annual interest to buy a car. If you pay it back in monthly payments for 3 years, how much will each payment be? Well, we're trying to calculate our payment right here, so that's our unknown. But we know the amount that we want is $12,000. 12% comes from right here, and we have to always use the decimal form, divided by 12, because you're going to make monthly payments. And that whole thing is divided by 1 minus 1 plus 0.12 over 12 times negative 12 times 3. Notice that there is a negative. It's a negative exponent. And we're making monthly payments for 3 years. So this is going to be 36 total payments that you're paying. So when we simplify some of that, we're going to have 12 times 0.01, which is 0.12 divided by 12, divided by 1 minus 1 plus 0.01 raised to the negative 36, which is 120 over 0.03108, or $398.57. When you get an answer to these, again, always stop and ask yourself, does it make sense? If you had a payment of a couple dollars when you got to this point, you know that doesn't make any sense. And let's say you found out that you had payments of $5,000, you know it doesn't make sense. So you want to look at your payment or your result that you get and ask yourself, is it reasonable? Does that make sense? So now let's look at a mortgage. Let's say you're going to borrow $200,000 to buy a house, and you're going to use a 30-year loan, and the interest rate is 6%. 6% right here. So what are our mortgage payments going to be? Well, we know we're going to borrow $200,000 times the interest rate divided by 12 because they're 12 monthly payments. And that whole thing is going to be divided by 1 minus 1 plus 0.06 divided by 12, raised to negative 30 times 12 because we have 30 years with 12 payments per year. So when we simplify all of that, we're going to have 200,000 times 0.005 divided by 1 minus 1 plus 0.005 raised to the negative 360th power, or 100,000 divided by 1 minus 0.1660419. And when you do all that arithmetic, you find that your monthly payment is $1,199.10. I purposefully write in all of these steps so you can check your calculator. So walk through each of these steps, putting it into your calculator, and make sure you get what I have so that you're sure you know how to use your calculator. Calculators are all different, so I try to show you each of these steps so you can check yourself along the way. All right, well, let's take that same mortgage, and let's say we're going to only borrow it for 15 years. So what is our payment going to be? Well, right off the bat, you should say, well, I know it's going to be higher because in the first example, we did a 30-year loan, and now we're only going to borrow the money for 15 years. So each monthly payment is going to have to be higher. So that ought to give you one tip, that if you get to the end of this problem and find something lower than you got in the first part, then you know that something's wrong. So if we use 200,000 again times 0.06 divided by 12, the only thing that's going to change is this exponent, because that's the only place we used our 15 years or our 30 years. So now the exponent will be negative 15 times 12. And when you work all the arithmetic, you get a monthly payment of $1,687, which is higher than the one we first got because you're going to pay it off more quickly. So let's compare these two options to find the total amount repaid. So under the 30-year loan, we paid $1,199.10 times 12 payments a year times 30 years, which means we're going to pay $431,676 for that $200,000 loan, or we're paying $231,676 in interest. If we look at the 15-year loan, we're going to have a higher monthly payment, but it's for fewer months, so we pay a total of $303,787, or a total of $103,787 in interest. So you can see the difference. Even though the monthly rate was the same, you can see the amount of interest that was saved by paying it off in 15 years rather than 30. So you have homework on pages 66 and 67 to get some practice doing these problems. Let me know if you have any questions.